All right, I think we can get started. So good morning, everyone. Welcome to lesson 4 with 7 people in the chat room. We'll be in the chat room all night. There we go. And share my screen.
Can I borrow your Astros? Huh? Can I borrow your Astros? Yeah. If you just grab them, just drawer, and then they're all the way back.
I'll mute you. That's funny.
Is the court's on there, right? Yeah. Alright, and with the one. Sorry. That's yeah, it's like it. I'll buy some headphones today, so this will be it.
Okay. I'll start all over again. So welcome to lesson 5 of computational thinking in data science. And messing with my screen a little bit to have enough working real estate to go through today. So to the right of the screen are the participant list, and I'm pretty sure you can see that, and the Zoom box. Let me shrink that a little bit, and I'll make that bigger. And we shall begin. So on the screen, I'm at the Blackboard site, and if we go into lessons, nothing happens. There we go. And today's topic are functions, and we're going to look at built-in functions, which you've already used, and we're going to look at user-defined functions that you build or design and define yourself. So in that lesson category, there is a quiz. So there's quiz number 4 referring to do loops and conditionals. So that's based on last week's lesson 4. And you can expect there to be a second quiz sometime this week. So currently this one is due on the 16th. So that should be plenty of time. That's Wednesday of next week. So your second quiz, when it appears, will also be, it'll probably appear in lesson 6. And we'll take the link to the lessons. And here we are at the content server. Seems to be running right now, which is a good thing. And lesson 5. So the lab for this has quite a few files in it, and I would suggest you wait until Farang starts the lab and walks you through that before you download too many of them. So I'm just bringing up the PowerPoint presentation, or actually PDFs of it, on computational thinking with data science, programming principles, functions, and variable scope. And you can see it's by Dr. Batu in mechanical engineering prepared these. And so the outline for today is to discuss what functions are, how to create a function, how to call a function, the concept of variable scope, and and we'll mention recursion, but we're not going to spend much time in it. That's a fairly useful but advanced topic and prone to a lot of confusion if you're just starting out in this programming game thing, especially if you're not going to be a programmer. But we'll mention it. So the objectives are to understand the roles, types, and usage of functions, and to understand and implement functions in Python under various configurations. To understand the role and types of variable scope, and to understand and implement variable scope in Python under various configurations. All that jargon will make sense in an hour. So functions in the computational thinking concept are an important part of the decomposition algorithm design portion of computational thinking. Variable scopes, same. And then recursion is a type of pattern recognition. So that's why it's included. So first thing is, what is a function? One definition is written here is it's a portion of code that you can easily use multiple times by calling it in the code. Basically, functions are packages of code that execute certain tasks. Let's see if the link comes through. So there's this nice YouTube link explaining a function, and see if I can get to it from my local machine. Can't get anything because all this software is in the way. That is not my desktop. There we go. This will have a functioning link in it, so let me just go to the link. I think it's a 3-minute video, and it's actually part of an experiment. I wonder if we can play the video while we capture a video. There we go. It must be doing something right because the graphics fans are coming on. You do that. You wait. And nothing happens. Oh, and you lose control of your computer too. Interesting. Okay, it's 1-minute video, so let's see.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art and magic is in defining your own new words out of these building blocks. We do this all the time in sports. For example, in basketball, you start by learning how to dribble, how to do a layup, how to rebound. Once you've learned these really basic moves, you learn new moves and put together these building blocks, like a pick and roll or a give and go. And you can then go from there to do more complex plays. And once you learn that play and give it a name, everybody on the team knows how to do it. Similarly, once you've taught a computer how to do an action once using these sequence of commands, you can make up your own name for that action, so it's easy to repeat it later. When you define your own command and give it a name, that's called a function.
When programming with blocks, you would use functions if there are a set of actions you're going to want to use lots of times. For example, you've written code to create a square. You can define this as a function called createSquare. And now you have a new block that you can use multiple times to create multiple squares. A lot of simple shapes can be used to create more complex patterns. In the next puzzle, the code you recently wrote to make a circle is available to you as a new function that can make circles of different sizes. Can you use it to help Elsa create an intricate and beautiful pattern in the snow?
Okay. So there was our introduction to functions at a somewhat different presentation level than we're used to. There we go. So what a function is, it's a group of script commands that can be named. You can name the entire group of commands and then just refer to the sequence of operations by the name rather than having to provide the individual operations. And so how they're used is they're only run when you tell it to run. You can provide to the function data through a collection of values known as parameters into a function. They're also known as arguments. You'll also see argument list. Those three are all interchangeable. And then the function can perform operations, and it can return having done that, and there's no record of that, or the function can return data as a result. And usually that's how we build them, is we actually want them to do something and report back to us what they've done or give us new values. They're useful for decomposing a problem because the functions can be used to modularize. So things you can do in a function: you can create another function, you can call another function. So functions being nested is quite normal. And in Python, the function is defined using the def keyword. So here on the screen is an example of creating a function. So the def keyword appears, and then the next sequence of characters is the name of the function. So this one's my underscore function underscore name 1. Then there's a set of parentheses, and what those parentheses do is they enclose the parameters of the function or the argument list. If the function doesn't need parameters to do whatever it's supposed to do, then that can be left empty, but you still have to put the parentheses and the colon. One way to view it is the parentheses are part of the function name. That kind of helps you not forget it. And then you have whatever's going to happen inside the function. Now, by inside I mean between the word def and wherever the ending statement is. Inside the function, we can create variables and assign things to numbers and do arithmetic. And unless explicitly declared as a global variable using the keyword global, those variables stay local to the function. And I'll show you what that means when we do a few examples. Here's another example, and this one actually has the keyword return. So if you forget the keyword return, in most cases the function will run fine and you'll have no knowledge of it. But in terms of programming style so that other people can read and maintain your scripts, I recommend that you put the return whether you do anything or not. Here we have return an expression, and this is how I return a value to my function name. Or you could leave return blank, and then all that's really happening is at the system level, the return is either returning a true or a false on whether the function failed. And if you do an exception trap, you can detect that. But usually if the function failed, other stuff would. in the main part of the program, we want to use the function. All we type now is my function name, parentheses, argument list, and use it. All functions in Python have a return value, even if you forget the return statement. Functions without the return statement return a value of none, which is a type of constant, same as a false. So I try in my own work to adhere to the habit of always having return from the function. And there's another reason to do that. We'll try maybe in lab. I believe you can have multiple returns in a single function. So you can have conditionals operated, and once a condition is satisfied, you can return from the function. Most other languages have that. I've never tried that in Python that I know of. So here's an example called the mySum function. Equals sum of n numbers, and then 10 is the argument. So let's see above what this function is supposed to do. Comes into the function, it has this argument named n. It sets a counter called mySum to 0, and then it goes from I in range 0 to n plus 1, so it goes from 0 to n, and it adds the value of mySum to itself, and then adds I to it. Actually, this particular script right here has an error, and I think we have sufficient time to test it, so let's go ahead and do that. New project. All right, create a file, Jupyter. Oh, I guess should have given it a useful name, Python 3. Okay, looks like we're live. So let's look at, pity I can't copy and paste that. I'll just type. So here we'll define the function. Okay, so there's the first line. Define mySum n numbers. And then we'll set a counter. Need to have the argument. And I'm going to do it exactly so that we can pick up the error mySum plus cap I. Okay, here's what was typed in the PowerPoint. And then return mySum. Now go ahead and run it, and either it's going to detect the error, actually two errors, it's going to detect the error, or it's just going to generate the bytecode associated with that block of code. Okay, so it won't detect the error until runtime. So now we've defined a function called mySum, and the next step is to use it. So to use it, we'll have print mySum. I got it. And let's go with 10. Actually, let's go with 3, because 1 plus 2 is 3, and 3 is 6. Okay, so that should produce a 6 if it works correctly, but we're going to get an error message. And the error is right here. The name capital I is not defined. Oops, what we meant to put was a lowercase I. Okay, so we make the change. And now I will rerun the cell where the function was created. Rerun the cell that did the arithmetic, and we get a 0. Interesting. Oh well. Let's see why that's so.
I think it's because the return statement is indented.
Oh, thank you. There we go. This should work a little better. Yay! Okay, so there's our first function, at least for some of us. Obviously my first, because I find the auto-indenting a little bit of a nuisance, because it allows those kind of mistakes to creep into it. So here's our function, my sum, n numbers, and here's using my sum of n numbers. And now let's see why we might want to use it. Okay, so look at that for loop that I'm copying down there. The other way to accomplish the same task would be do it for 1, do it for 2, do it for 3, do it for 4, do it for 5, do it for 6, 7, 8, 9, range 1 to 10. I think that's the equivalent of what the for loop does. Or we literally could take that and copy it 9 times. So the value of the function is we don't have to keep recopying this code in our input script. It will continue to work. And it's nice and compact. Once the function is working the way we want it, we never have to mess with the function again. We have to save it somewhere. Let's see if I have the split cell. Bingo, cool. Okay, so let's first run this where we executed the mySum function 1 to 9 times. And we get that. Now we'll do it in the for loop. And invalid syntax, forgot the colon. Same thing. So there's the function defined once. There's the function accessed 9 times in a for loop. There's the function accessed 9 times directly written. We'll call that spaghetti code up here, especially if it gets all mixed on itself. So some of the questions, so in order to use it, it does not have to be in the same kernel or cell. No, it doesn't have to be in the same cell. In fact, in the lab session, you'll be shown how we can put this into a file and then just import the file. I would attempt that here, but not live during the lecture part, because if it screws up, it'll confuse the heck out of you. Okay, well, we've pretty much done this, except we already know that this function will not work as written. And let's see what happens if we do it without a return statement. I'm just curious. So, and let me try that again. No return statement now. And so it gives us the value, and we're going to get none 10 times. So without a return statement, the calling script has no idea what to take from the mySum function. So all it can do is report back the status, and the status is none, meaning we've not instructed it to return anything. But we turn that back on, and we get the desired behavior. Now let's let me modify the script one more time and insert a cell. I think this will work. Okay, so what this command is going to do should reset this workbook. Okay, cool. So now I've reset the workbook. So in theory, the mySum function is no longer defined. So now when I try to run this cell, it gets this error. MySum numbers is not defined. If I run this one, I'll get a variation of the same errors. And it's like, what could be wrong? Well, it's because we've not defined the function. So the function has to be defined prior to its use. In C, this was called a prototype function. So you build the prototype, you didn't have to know what all the pieces were. And then when you invoked it, it became the operational function. So Python has kind of the same mental relationship. So if I simply run this cell, skip that cell, the function now exists because we've defined it. So a big source of errors coming up for you all is going to be something like that. You'll forget to define the function before you use it, or you'll make a change to the function. You won't rerun it, so it doesn't reset the code. I'll leave that out of there so that you all don't get in the habit of doing that. It's just for as needed right there. And that will be your biggest problem with functions. So another feature which is actually pretty cool, because the older programming languages that I was familiar with, such as Dinosaur, Parseltongue, and Pterodactyl, didn't have this property. In this case, when you do the definition, sum of n numbers, inside the parentheses, it has this syntax n equals 3. What that does is that puts in a set of default values, so that if the calling program doesn't provide a value for the particular parameter, a default value is provided within the function. Now the benefit of that is that as you're developing a complicated script to do something of meaning to you, it allows the script to keep running using the defaults. And so that if you forget a default, or if you forget a value somewhere, the program continues to run. It may be wrong, maybe producing incorrect output, but getting something to run to the end is nearly as important as getting something to run to the end and be right. So that's one benefit. The other benefit, if we have interactive input and the user doesn't know what number to put in, they can just choose to accept the defaults, and there are default values put there. And you've all done that in your day-to-day lives, I would imagine, when you download illegal software and you accept the defaults when you do the install, or you download legal software and you accept the defaults, give them a Visa, American Express, or MasterCard number, and do software. A lot of times when you're on websites interfacing with a web application, there are certain items you can't answer, and you can accept defaults, and it allows you to continue. In web design, the default is, has the customer entered a credit card number? If the answer is yes, take their money, regardless of what they answer. A bit cynical there, but sometimes it seems like that. So if we want to provide default values for our arguments, we can. And it's done here by just listing the argument with an equal sign. What you cannot do is you can't have some arguments without default values and then some arguments with default values. All the arguments that you're going to assign with default values have to precede any other argument. So my function n equals 3, comma a, comma b would probably work, but as written here, it would not. So let's go back to my example, and I'll go ahead and put in a default. Okay, so I set the default to n equals 10. I'll run these two cells, they shouldn't change any. They don't, but let's copy this one, paste it, and see what happens if we call the function without providing anything. So by leaving the input list blank, it's going to use the default that we gave it. Now watch what happens when we don't have default capability. We just saw this one work, so when I run it again, we get the pink screen of errorness. So it's missing a positional argument n, and so we can either give it a value or go back to our default way of defining it. So variable scope and type of scopes. So a variable and its contents are only available in a namespace that is created for. For example, a function or a main body of code, and that's called its scope. So the types of scopes are the local scope, and that's a variable that's created inside a function, belongs to the local scope of that function, and can only be used inside that function. So this variable here, my sum, is only part of my sum of numbers. And we can test that conjecture unless the Jupyter lab is going to make a fool out of me, which it might. Okay, so in theory, my sum should not be available to this calling script because it has no idea what my sum is. And indeed, that's correct. My sum is not defined. And we go back up here and say, wait a minute, I defined it right up there. WTF? Well, the my sum variable is owned, if you will, by the my sum n numbers function. And nothing can get to that variable unless we provide it access via an input parameter and then operate on that input. We don't have very many interesting variables in the main program right now. We got J. Let's see if we can print J. Actually, J may be part of the for loop ownership, but okay, we should still get the error. Yeah, we got J equal to 9, but we still can't print my sum. So that's what's meant by local scope. we can have functions inside of functions, and in that case the variable is not available outside the function, but it is available to any function inside the function. So if we had a function within the mySumNnumbers function, that function could access the mySum variable. And I don't have a good quick example that I can think of off the top of my head to illustrate that, so I'll skip it. But we'll try to get to it in lab. And then a variable that's created in the main body of the code is, with the explicit definition of global, is called a global variable, and it belongs to the global scope. And global variables are available from within any scope, global and local, that's within the namespace that's being operated on. As a test of that, I can't test it. I have to create another function here to access. The only variable we have is j, and I guess we have j, and it's not very interesting. Let's try something fun here. Okay, so j is available to the main program. When we run this, a whole host of errors. Oh, interesting. It was able to access the value of j. And then we get the mySum error in right here. Let's press that, run it one more time, and we're actually going to learn something very interesting. Okay, so j is a variable that belongs to the main program. mySum belongs to the function. We already know we can't print that. But within the mySum, it has access to j, and of course its own values of mySum and I. And so now it's printing the mySum I, j, the return, mySum I, j, the return, and so on. Keep that in mind as you're making your own programs in the future, especially when they get complicated. That can be a source of very difficult to run down error. If you operate, and so some of the tricks are by using the naming convention to control that. So if you operate with the same variable name inside and outside of a function, they're treated as two separate variables, one available to the global scope, one available to the local scope. If you need to create a global variable but you're stuck in local scope, you can use the global keyword, and the global keyword makes the variable global. So let's look at an example of that. See what this does. Oh, actually, I think I can actually do the assignment. I'm going to do it this way unless it errors out on me. Okay, so I've just made mySum a global variable. And we'll run this. And now everything works as desired. We can go suppress this output here. Ta-da! So there's the global-local relationship. The arguments that a function can have are in different classes. And we're going to learn about classes on Thursday, but we've been using them all along, but we'll talk a little bit more today. There's a Boolean class, or logical, an integer class, floating point class, string class, tuple, which is an immutable sequence, a list, which is a mutable sequence, a set, which is an unordered set, and a dictionary, which is a associative or a key mapping. All these can be passed to a function through its argument list. And then once it's in the function, booleans, integers, floats, and strings and tuples can be modified. You can change their contents by operations in the function. A list, set, and dictionary are not modified by a function. It's possible to have function definitions inside other function definitions. So we can have a outer function, an inner function, a return, another inner function, and then back to our outer function. And in this case, this has my function name of 1, 2, which actually is a statement. The question is that a bad function call or not as written? Let's say that's that my function name 2, 1, 2 is trying to get to this inner function, and it has to be passed by reference through my function name 1. And that will become apparent as you explore nested functions. There's quite a few built-in functions in Python. The print function, for example, is built in, and it's a function. We use it as if it's just somehow part of the language. And there's also the math package, which we've seen last time, we introduced in lab, which has a collection of functions like square roots and sines and cosines. And those are accessed with the, first you import the package, then to access the function you use the math keyword with a dot and then the name of the function and its argument. Or Farang showed you a way to import that to just use the name, which is probably preferable in our work. And to learn more about the math functions, you can go to the Python math library, and they have a whole list of what they are. And then here's how to import them by specific name. So you have from, package name, import what. So in this case, from the math package, I want to import the square root and the sine function. And the example's done here. So the next example So the next example is shown here, and I think I have these scripts set aside somewhere, so I'm going to go take a quick look. Luckily for you all, the cat has decided to lay on the keyboard. Oh, come on, dude. Give me my... That was pretty impressive. You like wiped everything, cat. Where was I headed here? So I'm going to a different server than CoCalc because I think I have these examples already built. If I can find them, I use them. If not, I'll forget about it. Looks like I don't have rats. Okay. So in the interest of time, I'll just describe these. So let's see what we can do just by looking at it. Here we have a function named a, has no arguments. So whenever the function a is called, it's going to print the local value of x in a is x, and so it'll print 25 after entering a. And then it's going to increment x by a value of 1, so x will have a value of 26. The local value of x in a is 26 before exiting a. And now here's a second example where we have the global definition. So here we have a function b, no arguments. It has an internal variable x, which we have just globalized. We're giving it a passport. So now we have print global x is the value of x upon entering b, and then we do assignment multiply x by 10, so it's going to be 10x on exiting b. And now here's the main controlling script. Print global x is x, and what it'll say is it's null because we've not defined x yet. Then it says x equals 7. Now we print global x is, and the x is going to equal to 7. Then we run the a function, and what it tells us is 25 and 26. Then we run the b function, and it gives us 7 and 70. Then we run the a function again, it gives us 25 and 26. Then we run the b function again, and it's going to give us 70 and 700. Why would the b function the second time give us the 70 and the 700? It's because the b function, because we've globalized x, when it makes its operations on x, they're not lost when you exit the function. So they're stored in the memory stack. And so the next time we access it, it uses the last value that was in it. For what it's worth, this would be a fairly goofy way of programming something like that. But you could do it. The next function is recursion. And these are functions that call themselves. There's a certain depth to recursion of how many levels of a function calling itself there are. It's reasonably big, but it's by no means infinite. By reasonably big, in the hundreds. So if you have a function that has to call itself, you have to have some prior knowledge to know that it's not going to do that too many times, because this is a worst case infinite loop if that happens. You'll be pulling the plug on the computer to stop it from burning electricity before you get this solved. So be wary of recursion. So here's an example called my function that prints hello, and then it's going to call itself, and then you initiate it with this function called my function. So you need to have some way to terminate it. And we invoke the function by calling the recursion steps. So probably the best example of a recursion function is factorial. And then we have a base case. And then we return n times factorial n minus 1. And then we can print the result. So here's an example of what the base case is. And there's also a built-in string function. I'm intentionally only briefly touching on recursion. It's a fairly advanced topic and not necessary initially for the latter part of this class. There's many useful functions of Python with string applications, and we can look at the uppercase and lowercase method, which is attached to the string function. And in the methods are invoked by the method name that follows the string variable with the dot. So literal hitchhiker dot replace is the string hitchhiker as a string, and we're applying the replace method. And the replace method is find the first instance of hi, replace it with ma. So let's go ahead and take a look at that exact example. Okay, so there's my string, and I'm going to handle this a little bit differently. I'm actually going to make an assignment. So there's my string, the hitchhiker. And it returns hitchhiker. We'll replace all the first instance of hi with ma. Excuse me, all instances of hi with ma. And we get matchmaker spelled wrong. Ah, I spelled hitchhiker wrong. I didn't know how to T in it. Okay, string methods can also be invoked using variable names such as, oh, we just did this. Note that in the string variable equals s dot replace doesn't change the string s, which is still train. The method call has a output value which gets put into T. So let's follow that particular example. So I have train, and I want to do a replace, put into a new variable. I want T for ing. So I'm going to take my string, which is currently train. I'm going to replace the T with an ing, and I'm going to assign that to my other string. And then I'll print my other string. So now it's engr. And then I'll replace the n with a de and send it to yet another string. And what we get out of it is degrade, just like the example. And this statement is that my string, my other string, and my 222 are now all unique strings. So we didn't destroy the original string. So we have train, engrade, and degrade, all available to us. The replace function is not unique to strings. It can be used for some other types of objects. Okay, so that's our introduction to Python functions. 9 o'clock. Let me reiterate some important messages. There's quizzes. Remember to check those and take the quiz as soon as you feel ready. I've programmed them to have you get at least 2 tries. So, and this one can be saved and resumed later. So there's no excuse not to do really well on the quiz. Maybe not perfect, but really well is quite achievable. Moving into Laboratory 5, there's the Laboratory 5 assignment, which we'll get to shortly. This one has 9 points, and when you're completed, you'll upload your files. Ooh, I think I have to change something. You'll upload your files. I don't think I have it set for file upload, so we'll fix that. I think edit does it. I guess I've got it right. I apologize. I'm a little confused with Blackboard most of the time anyway. Okay, so there's your Lab 5, and I'm going to go ahead and switch to the Lab 5 setup and start to explain it. And then we'll take a break, and we will return, and we'll have Farhang lead us to the lab. So in the Lab 5 directory, you see there's a bunch of stuff here. Okay, there's one called Full Narrative HTML. I'm going to click on that. Just watch. Don't do. Just watch. And it has pretty much what's in the Lab 5 notebook. So the notebook's written for you to read it. So you're going to want to read it, and bear in mind the HTML doesn't do a perfect rendering of what you would see in a Jupyter notebook. So this particular notebook is dealing mostly with functions, a little bit on packages. Here's a typical program flow control for your Jupyter notebook. Imagine that it's executing from the top down. That's what these arrows are. These are representing program execution path. So usually we would import a package so that we have access to it. And later on, if we're going to make our own function, here we have define my function, dummy parameters, and then the actual definition. Then later on in the script, we have some value is equal to package name dot function name some input. Then we set actual parameters to some numbers, and then we would use my function. Oh, this should be actual parameters, goes to some other volume, and the rest of the cells. And then there's a few examples. Okay, the examples, when you first load them, should have this import and that from suppressed. The first two are supposed to generate an error, and then you're supposed to go in and remove the comment sign and rerun it and find out that it works. And that's to illustrate the importance of not having the package loaded. Also, in these ones, I'm using the reset function, which is a Jupyter Lab function. Normally, you don't want to do that, but here I'm resetting the notebook each time for the sole purpose of clearing out these definitions so that they don't have access to each other. The list of built-in functions is shown next. It's just presented as a list, and you'll notice all of them have very function-like looking structure. which makes sense because they are a function, except import, which has something called a constructor type function structure. And to import something, we just use the keyword import as if it were a function. But that's the import function. It's not meant for normal use, and we'll learn about it later. Then we discuss the add-in packages and libraries, for example, math. And here's some different examples of doing imports. Again, with resets each time, which is sort of interesting with this random number generator. Sometimes you actually get the same random number 3 times with the reset. The modules that come with Python are fairly extensive, and you can learn more about them at this URL. And then we get into the fun part, which are user-built functions. And you've seen me do a few examples, really simple examples. Function name, argument, and return expression. I incorrectly have these in square brackets. There is no scoping delimiter associated with the return statement. The keyword define tells the program that the indented code is the function. The keyword return tells it to return an answer. There can be multiple return statements. Once the function executes a return statement, the program exits the function and continues with its next executable statement. And then we're going to go through a few examples. So first you'll build the Dusty function, which is named after this beast which is sleeping on my keyboard right now. So here we have the function, and then here we have the code that uses it. And I'm calling these codes wrappers. In some contexts, that's what they're referred to. So this code wraps around the function to give it functionality. Then there's a couple more examples that you'll work on live. And then there's the first exercise. Exercise 1, you want to create this function. And then you're going to want to write some sort of wrapper script to use that function to build this table. And this doesn't have to be elaborate for this part, because you notice the spacing there is 0.5, then 0.25, and it's not uniform spacing. So your goal in this one is to actually get a table back that more or less makes sense. So conceivably you could just define X as a list and hand type in the numerical values. That would be adequate for this exercise. Then there's some discussion on variable scope, and we've seen that in the lab, in the lesson. And then an example on doing these as separate modules. Okay, so here's the real power of function. So we can define the Nico function, usual fashion. Only in this case, we're going to store it in a file that ultimately will be called mylibrary.py, and then modify the wrapper script to use it as a module. So once we've saved our function in mylibrary.py, we don't have to do the definition ever again. We just have to import the library and then access the function using the package name, function name, argument name. I'll do this example live shortly because this is somewhat complicated. But I name these external user modules because I can't think of a better name. So this left box here represents your notebook. In that notebook, you're going to import a package name, and that act of importing establishes a logical and data path connection to the package name, which in our case is my library. Within my library, there's this my function definition, whatever it does. So you can logically think of what happens with the import. As the notebook's executing, it comes across import package name, it finds the package, and then it takes the contents of that package and it sticks it right there. And then continues on about its thing. And once it's done that, you have access to the my function. And then we will conclude with getting a bit ahead of ourselves, drawing pictures. So these are going to be presented as packages and functions. At this point, there's no expectation for you to know all the features of the matplot library. We're just going to have a select few. So first you'll produce this plot, and then we're going to show you how you can take all that garbage that does the plot and put it into your own function, which I've called plot align. And so here's a function that imports a library and then builds a plot based on the data you give it. And then when we actually want to make the plot, the wrapper script is quite a bit easier to interpret. We basically tell it to plot a line, and we tell it what the x values are, the y values, what we want the x-axis to be labeled, what we want the y-axis to be labeled, and the name of the plot. And then I've got some little extra stuff here for integers and flows. And then Farang has an example for you to draw a straight line between 2 points. And then make some other plots. So this will be an interesting exercise for you. And then you're going to want to use the plot align to plot y equals x squared, because by that you'll know how. And then the last exercise is to plot what I think we had is the Dusty function, and make a plot where x goes from 0 to 15 in increments of 0.25. Label the plot and plot axes, render the worksheet, and you're done. Okay, so that's the HTML. The actual notebook that does that is the one called Full Narrative IPython. There's another one called Worksheet Only, and all it has is everything but the narrative has been removed. So in terms of keeping track, you may choose to do that. Here are 3 PNG files, and those are the graphics that are in the notebook. And then here's my library file, unreadable because that's in the way. So there's what's in my library.python. But what I'm going to demonstrate, and then I'm going to hand the lab over, is how this gets created in practice. So the first thing I want is save that. I'm going to need that. Need that. So what I'm downloading is everything I need to recreate that workbook. What I'm not going to download is my library, because we're going to build that on the fly. Okay, so now I go to CoCalc and go into my file manager, and I want to add, I think it will let me drag and drop. We'll find out in a second. Yay! Okay, so let's go to the full narrative. Let it load. Let's see if it got the pictures. It did. Okay, so that's pretty much what I just showed you. I'll leave this be. I just want to demonstrate the external modules. Okay, so I want to build the Nico function live, and the way to do that is I need to create a new file. I want to make a Python. Need to give it the right name. see what happens if we do this. File type. Cool. So in my file manager, I indeed have the library file. So I want to make the Nico function. Import, check, local variable. I'm typing a comment so that it detects that I've changed the file and lets me save it. All right. Let me make one more quick change here. I am going to rename this. Okay, I'm giving it a name, my library PPPP. And I'm going to do that so that when I run the Nico function, it fails. Because I want to show the whole point of doing that. Okay, so here's the Nico function. You just watch me do it. When we go ahead and run this, it's going to import my library. It won't be able to find it because it's not there. And we get module not found. No module named my library. Like, oh, my bad. Let's go back and give it the correct name. Now the library is there. Let's see what happens now. Probably the same error. Unexpected indent. Okay, I have an error in the library. All right, if you say so. You are the computer. Unexpected indent. Ah. Little indentation error. There we go. That should work better. Now we run it, and lo and behold, the Nico function is there. And we're done. Okay, everybody take a 5-minute break. I'm going to hand off control to Farang and get everything set up for him to run the lab. So the key thing on the lab, full narrative Python notebook or worksheet only Python notebook, either's fine. And if you want the pictures, if you grab the full narrative, you want to pull base functions, external file, flow control, diagram. If you want the Python library to run without messing around, also grab the My Library file. Don't worry about the PyCache. So that's actually what it's building when it makes these when you make these libraries. So I'll repeat that again: full narrative, base functions, external, flow control if you want the pictures, and then My Library if you want the function already built. All right, so 5-minute break, and I will set up the next video. So that's good. That's good. Shrink that. Shrink that.